Okay, today I'm integrating the product x squared times sine 4x with respect to x. I'm going to be using integration by parts. There's the formula. The integral of u dv equals uv minus the integral of v du. What I want to do is make u my x squared and dv my sine 4x. And the reason I'm doing is that I know that this will eventually differentiate out the factors. Whereas I know that the sine, any sine or cosine, any trigonometric function will continually go around it. So if we start by letting my u equal x squared, and from that I can find my du dx will equal 2x, or du equals 2x dx. Easy enough differentiation. When we come to the dv part of the equation, dv will equal sine 4x, with respect to x. That whole part there. I know that the integral of sine of a to the x is equal to minus 1 over a cos a to the x. So using that, it's a minus 1 over a, which is 1 over 4, cos the angle 4x. So I have my four parts, u, du, v and dv. I can go ahead and write out the equation now. The integral of x squared sine 4x with respect to x equals, my u is x squared, my v minus 1 over 4 cos 4x minus the integral of v du. Of course I know my v is 1 over 4 cos 4x and my du is 2x dx. I want to tidy this up a little. So if we bring this out, it's minus 1 over 4 x squared cos the angle 4x. If we look at this term here, we can bring the two minuses together, become a plus, and that will be the integral 1 over 4 times 2, which is a half x cos the angle 4x with respect to x. It's a little bit tidier now. But what I'm going to have to do is take this term and go again, because we have, again, like the original formula, we have an x term times a trigonometric term. It's another product, we can't factorize it out, so we're going to have to go again. So I'll bring it over here. Write out the equation again. The integral of a half x times the cosine of the angle 4x with respect to x. Again, we're going to have to pick the u and the dv again, and I'm going to stick with using the algebraic term. Let u equal a half x. Again, once I do my differentiation, find the derivative is a half, and note this is now a factor, or du equals a half dx. Again, you have to return to the dv term, which is cos 4x with respect to x. And to integrate this, again we know that the integral of cos a to the x is 1 over a sine a to the x. So using that, that's a quarter, there's your a, sine the angle 4x. So now again we have our u, du, dv and v term. We can go back to this equation. write it out, the integral a half x cos 4x with respect to x equals, and we go again with our original formula, uv is a half x is our u, and our v is a quarter sine the angle 4x minus the integral of v du, the integral of v du, which is 1 over 4 sine 4x, and our du is a half dx. Now, again, I want to tidy this up just slightly. So a half times a quarter, that will become 1 over 8x sine the angle 4x minus the integral, half times the quarter is again 1 over 8. You notice the absence of the x, it's just sine 4x with respect to x. And we can go ahead and integrate this now. This is a straightforward integral. Continue on, 1 over x, 1 over 8x sine the angle 4x minus 1 over 8 times, we'll bring 1 over 8 outside, you've got sine 4x again, so we know that the integral of sine 4x is minus 1 over 4 cos 4x. And that's it. So we're going to tidy up a little here again. Over 8 sine 4x. The two minuses become a plus, and that's 1 over 32 cos 4x. We have to remember that this is the integral of this term, which is the second part of the original term. So if we go back to the original, which was x squared sine 4x with respect to x. We'd initially taken half of that out as minus 1 over 4 x squared cosine 4x. Then we had a plus, and this term, this integral term, which we found to be this. So because it's all pluses, we can dispense with brackets and write it straight out. So I have 1 over 8 x sine the angle 4x plus, I'll just continue over here, 1 over 32 cosine 4x. Now that's the answer, but we can tidy up a little. And we find it that is equal to 1 over 8x sine 4x, that's the sine term, and I want to get the two cos terms together, minus 1 over 4 x squared cos the angle 4x plus the last term 1 over 32 cos 4x. Finally, I will want to write that as just one sine and one cos term. So 1 over 8 x sine the angle 4x. The two cos terms come with factors, so I can factorise them out. And the common denominator is 32 there, so if I put 1 over 32 times these two factors here, which is an x squared by 8. So 8 times the 1 over 4 is 1 over 32. So it's 8x squared. Because that's the minus term, that's okay, but this is a plus term and I've used a minus factor, So this becomes a minus 1 over 32, that's a 1, all times the cos 4x. And don't forget your c. That's the answer.